make sure I'm recording, right? And as I said, I'm gonna post yesterday's thing tomorrow. I'm a little behind. Right? Tomorrow's Friday? Yeah. I got you. Maybe, maybe. All right, so look, this is what we're gonna do right now. We're interpreting probabilities. Go ahead. Mhm, mhm. All right, that's fine. That's fine. Oh, I got you. Yeah. Mhm. Yeah, I got you. Please do. Huh? Yeah. Yeah. That's fine. That's fine. Just watch a video. It's all good. There's no test tomorrow, so yeah. Got you. Got you. Nice. But you got to bring back pictures though. Just like you. I got you. Or like a porn star, something that I don't have to see too much of their family. I mean, you see Cardi B. Hey, how are you? Did y'all know that she went to CUNY? What? Huh? Huh? But there's yeah, Nicki Minaj went to Kingsborough? I had no idea. Wow. Y'all know J Lo went to Baruch. Yeah. Yeah. Keith Sweat was City College. Yeah. Huh? Oh yeah. What was I gonna say though? I don't know this guy's name, but the CEO that passed away of Golden Crust, that's BCC. Mhm. Yeah. Yeah. Yeah, that one. That same guy. Yeah. Yeah. I mean, that's one reason why I was saying we have this food problem at BCC. Why we don't have a Golden Crust here? I mean, the CEO graduated from here, so they have first starting. Well, nothing is the same. True. They sacrificed quantity for quality. So we need to oh, that's what the not True. All right, let's jump into this real quick. So we interpreting probabilities, right? So as stressed in item 3, right, in the summary about probabilities, the closer the probability is to 1, the more likely the event is to occur. The closer the probability is to 0, the less likely the event is to occur. However, just because the probability of an event is very high, it is not a certainty that the event will occur. Likewise, even though the probability of an event is very low, the events might still occur, right? Events with low probabilities but big consequences are of special concern, right? Such events are sometimes referred to as black swan events, right? As discussed in a very popular book called The Black Swan by, I don't know how to say his name, Talby, whatever. In his varied careers, right, Talby has been a stock trader, author, and professor at the University of Massachusetts. His special interests are mathematical problems of luck, uncertainty, probability, and general knowledge. So, in his book, The Black Swan, he discusses the impact of highly improbable if an event has little impact, bearing, or meaning on a person's life, and a very low probability, then it seems reasonable to ignore the event, right? So if you guys have a chance, read The Black Swan. Hmm. Did you? Scott. Now we're going. Let me get some more. Oh yeah. Get that out. Get that out. Get that out. With the definitions of all the words. Sure. We still waiting for the definition. Yeah. I got you. I got you. Don't worry. All right. However, some of the really big mistakes in a person's life can result from misjudging either the size of an event's impact or the likelihood the event will occur. An event of great importance cannot be ignored, even if it has a low probability of occurrence. So, what should a person do? Taleb describes himself as a hyper skeptic, right? When others are gullible, and gullible when others are skeptical, right? In particular, he recommends being skeptical about mentally confirming an event when the errors of confirmation are costly. Lots and lots of data should not be thought of as confirming an event when a simple instance can disconfirm an important and costly event. Talbot recommends that one be skeptical in the face of wild randomness and big consequences and gullible when the randomness and consequences are mild. One way to estimate the randomness of a situation is to estimate its probability. So, estimating the consequences of an event in your own life must be a personal decision, right? Yeah. All right, so let's keep going. What does probability of an event tell us, right? So the probability of an event A tells us the likelihood that the event A will occur. If the probability is 1, the event A is certain to occur. If the probability is 0, the event A will not occur. Probabilities closer to 1 indicate that the event A is more likely to occur, but it might not. Probabilities closer to 0 indicate that the event A is less likely to occur, but it might. All right. So there's that.
So basically, in other words,
Mhm.
interpretate, right?
So basically, like mathematically, we're calculating the likelihood that something will or could happen, right? But it doesn't mean that it will happen that way, you know, something like that. Mhm. Mhm.
Zero, no. So for example, it's between 0 and 1, right?
Exactly.
For example, 0.5 would be likely to occur where versus 0.1 is not likely
Right.
to occur, yeah.
But it doesn't mean that 0.1 can't occur or won't occur, just less likely to occur. Yeah. Mhm. Right. It's possible, it's just not probable. That's why. Yeah. So the probability of event A applies only in the context of conditions surrounding the sample space containing event A. For example, consider the event A that a freshman student graduates with a bachelor's degree in 4 years or less. Do events in the sample space apply to entering freshmen in all colleges and universities in the United States or just a particular college? Are the majors specified? Are minimal SAT or ACT scores specified? All these conditions of events in the sample space can affect the probability of the event. It would be inappropriate to apply the probability of event A to students outside these described in the sample space. All right. Good stuff. Good stuff. Okay. Diving into probability over here. All the good stuff.
This is not too bad. I like this 0 to 1 probability stuff.
That's good. It's the hardest topic in the whole class. Mhm.
I don't believe you when you talk.
Yeah, it's true. Oh, no, the rest of those are easy. This is the hardest one.
Joke around a lot.
But once you understand this, you're good to go.
Or until you-
Yeah. So if we know the probability of event A, then we can easily compute the probability of event not A in the context of the same sample space. So the probability of not A is equal to 1 minus probability of A. That's our complement that we spoke about. The complement, right? Remember what we spoke about yesterday with that? Yeah. Yeah. Mhm. It's the opposite of the event occurring. So probability related to statistics. So we conclude this section with a few comments on the nature of statistics versus probability. Although statistics and probability are closely related fields of mathematics, they are nevertheless separate fields. It can be said that probability is the medium through which statistical work is done. In fact, If it were not for probability theory, inferential statistics would not be possible. That's so sad. Put very briefly, probability is the field of study that makes statements about what will occur when samples are drawn from a known population. Statistics is the field of study that describes how samples are to be obtained and how inferences are to be made about the unknown populations, right? A simple but effective illustration of these differences between two objects can be made by considering how we treat the following examples, right? So example of probability application, right? Condition. We know the exact makeup of an entire population. For example, given 3 green marbles, 5 red marbles, and 4 white marbles in a bag, draw 6 marbles at random from the bag. What is the probability that none of the marbles is red, right? So in that situation, we know the whole population, right? Okay, sure.
So, use that, line for that,
Hmm?
or using that A1 minus three percent solve that?
I could. This is just the whole point of this is just an example to show you that in this story, this example, I know the entire population. All right. So let's look at another example. All right. A little different, right? So in this condition, right, we have only samples from an otherwise unknown population. So let's say if I said to draw a random sample of 6 marbles from an unknown population of all marbles in a bag and observe the colors. Based on the sample results, we make a conjecture about the colors and numbers of marbles in the entire population of all marbles in the bag, right? So in the first story, I know the whole population, I know the whole bag, right? But in the second story, I don't know how many is in the bag. I'm just taking a sample from the bag and I'm doing whatever with it, recording their colors. Huh? So good stuff, good stuff. Mhm. They can give you different questions, yeah. Hmm. Yeah, I got you. Yeah. ChatGPT is good for that. Hmm. That's what I do. Go ahead. Mhm.
Like your definitions, a little too fancy for me. I know it shouldn't be, but it is. So the whole point of a probable application is that you know the exact makeup of the entire, okay, hold on. The point is you know the damn colors of the marbles.
Hmm.
And in the statistical application, you don't know the colors of the marbles, correct?
Pretty much. Yeah.
Why
Mhm.
That's so confusing.
Because it's scientific. You know? All right, so look, in another sense, right? Probability and statistics are like flip sides of the same coin. On the probability side, you know the overall description of the population. The central problem is to compute the likelihood that a specific outcome will happen. On the statistical side, you know only the results of a sample drawn from the population. The central problem is to describe the sample, descriptive statistics, and draw conclusions about the population based on the sample results, which is inferential statistics, right? So in statistical work, the inferences we draw about an unknown population are not claimed to be absolutely correct, since the population remains unknown in a theoretical sense. We must accept a best guess for our conclusions and act using the most probable answer rather than absolute certainty. Probability is the topic of this chapter. However, we will not study probability just for its own sake. Probability is a wonderful field of mathematics, but we will study mainly the ideas from probability that are needed for a proper understanding of statistics. All right. So, long story short, right? When I have a population that I don't know about, I take samples from it, right? From those samples, I can run what they call descriptive statistics on it. Mean, median, mode, range, the whole 9 yards, all that good stuff, right? Standard deviation, variance, all of that, right? Now, why am I doing all of that? I'm doing all of that so that eventually I can make a educated guess as to what the population parameter is, right? So for example, I don't necessarily care what everybody thinks about the mayoral race in this classroom, right? I care about what New York City thinks, right? But I can't physically go to everybody and be like, yo, what do you think? What do you think? What do you think? What do you think? Right? So I take a sample, this class, right? Ask y'all opinions on it. And then based off of that, I can make an educated guess as to what New York City feels. Right? Right. Right. Mhm.
That's called what?
So that's inferential statistics. Yeah. Mhm.
Statistics is a sample of a sample?
No, I'm using a sample to make a prediction as to what the population parameter is.
Oh, a sample.
Yeah. Mhm. Interesting, right? All right. Bear with me 1 second.
I think it's an already, you guys, it's not values, but.
I don't mind if it rains when I'm home.
Right, exactly, the
Yeah.
when we're home, not when we're outside.
Even better if it rains when like at nighttime when I don't have to go outside.
Think he's done cooking dinner, I think he's done.
Right? That's it. You know? Mm, mhm.
At night. Oh, my God. If you had words. Especially in the beach, because the sun is someone who always leave, so. I hate that,
Mhm.
it video really can leave. Rain when I'm up and aware and making sure that everything is good. I sleep better when it's raining. I can go there. Like, I only went under my bed.
Mhm.
I hate, you know what I hate? I hate when it rains in the morning and it's bright as fuck in the afternoon, like. Yeah, that throws me off. I don't like that shit. Like, how dare you? You're lazy and how dare you? Where I'm from.
You know,
So, yeah, that
you know
throws
what,
me
you know what
off.
I like though? Like when it's about to rain and then it don't start till like I actually get home. Like I actually go in the door and I'm like, oh shoot, I just missed that.
Yeah. That happens to me.
Yo, best feeling. What's that?
Winter, when it's about to snow, when there's supposed to be like a snow blizzard, it gets really hot. Yeah. Like really, really hot.
Mhm.
Yeah.
All right, so let's take a little detour real quick. All right. So we're gonna jump to algebra for a second. All right, solving literal equations. Yay. Mm, not that one, the algebra one. Hmm, That's this. Thank you. All right. All right, so let's go through this real quick, right? This is going to be really, 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 really simple. Okay. So solving little equations. So the method outlined gives an effective procedure or algorithm to solve any linear equation in one variable. It turns out that this algorithm is also effective in a more general symbolic setting. A literal equation or formula is an equation relating to two or more variables. So for example, right? Say I have f is equal to 9 over 5 c plus 32. That's supposed to be Fahrenheit to Celsius conversion. That's what that is, right? I equals PRT, right? Interest, right? H squared equals A squared plus B squared, and Y equals X squared, right? These are four different little equations. The first relates to two variables, F and C, representing the temperature in degrees Fahrenheit and Celsius. The second relates to four variables, I, P, R, T, representing interest, principal, rate, and time, respectively. No, that's good. That's good. The third relates to the three variables H, A, and B, representing the lengths of the hypotenuse and the two legs of the right triangle. The fourth relates to two variables X and Y, representing the coordinates of a point on a particular parabola. Such relationships are common in the world, and formulas give a concise way of describing them. A literal equation is linear in a given variable if the only operation involving that variable are addition, subtraction, multiplication by a constant or another different variable. For example, the equation I equals PRT is linear in each of the four variables. The equation y equals x squared is linear in y, but not linear in x. The equation a squared is equal to a squared plus b squared is not linear in any of the three variables. You will notice that three of the four examples of literal equations are written so that one of the variable appears by itself on one side of the equation with, let's continue. One sec.
Literal equations, right?
Right now I'm giving you the science behind it, but it's really, really simple to do. All right. So with no algebraic operation indicated, in the equation, h squared is equal to a squared plus b squared. The variable h is not by itself since it is being raised to the second power. Many formulas are written in this format. It indicates that the value of the variable appearing by itself can be determined knowing the values for each of the variables on the other side. For example, given the simple interest formula I equals PRT, suppose we are given that the principal amount is $2,000. The annual interest rate is 0.1%, or R is equal to 0.001. And the time invested is 3 years, T is equal to 3. The formula implies that knowing this information, we should be able to determine the interest earned. So substituting the given values into the formula, right? We have I is equal to PRT, right? 2,000 times 0.001 times 3, I is equal to 6, right? Yeah. Because when you realize what that means, it's like, what the fuck, right? So this is a linear equation whose only solution is 6. So the interest earned on the principal amount of $2,000 over 3 years at an annual interest rate of 0.1% is $6. That's some bullshit. All right. So we will notice in this example, in the preceding paragraph, that the mathematics involved in using a formula to determine the value of one variable when the others are given does not involve much algebra at all, at least when the variable to be determined is by itself on one side of the equation. All that remains given the values of the other variables is evaluation, right? However, for many reasons, right? It will often be convenient to rewrite the literal equation so that a given variable appears by itself. When the equation, right, is linear in a given variable, we can apply the method of the last section to solve the equation in terms of the given variable. Notice that this is an abuse of the meaning of the word solve. In fact, we're not solving the equation at all, which would involve finding the values for all the variables for which the equation is true. Nevertheless, the terminology is so common that it would be futile to avoid it, right? So no formula, you're just solving for variables.
Oh,
All right. So let's run through a couple examples real quick. All right. And don't worry, I picked the hardest examples that I could find.
what?
Yeah, I picked the hardest ones because I'm trying to confuse you. That's fine. All right. So in this question, right, I have I equals PRT and I want to solve for T. All right. So I equals PRT. And I want to solve for T. How do I do this? Don't overthink it. Okay, describe. Tell me what to do. I want to solve for t. I want t by itself, not t. What's next to t? All right. So I want to get rid of r. How do I get rid of r? Not take away. So when I have these next to each other, PRT, they're being multiplied.
There,
So how do I get rid of the r? Divide it, right? So I'm going to divide by r. But what I do to one side of the equation, I have to do to the other side of the equation. So now what do I have? I have I over r is equal to PT, right? I still have that P there. How do I get rid of it? Divide, right? So I'm gonna divide by P. What I do to one side, I gotta do to the other, right? Right? So what's my final answer, right? I have I over PR is equal to T. Mm-hmm.
Okay. Oh, wait,
And that's
you
it.
divided R from the P, not the T. So you want R divided by R and P divided by R?
P divided by P. Oh, you mean on the left-hand side, this thing?
Well, why
This
would you
thing?
put a-
Because they are. Because look, this is like P over one. Keep change flip, all that good stuff.
Don't speak about. So this P,
Gotcha.
P,
Mm-hmm.
R, and then P.
So it's right, but if you divide it by on this side
You gotta do to the other side.
to that side. I
Mm-hmm.
mean, of course, you gotta do past that, but I'm saying like,
Mm-hmm.
after you divide it, it just becomes the denominator.
Mm-hmm. That's it. If it was me doing this question, right? I'm a little bit more advanced. So this is my way of doing it. So look, I have PRT, right? So I want to get rid of the P and the R. Very simply, I'm going to divide by the P and the R.
See,
But what I do to one side, I do to the other. And that's it.
Okay, teach, that is way more than a problem.
That's my way of doing it. You know? No formula. This is just solving a literal equation. It is easy. Mm-hmm.
And that becomes I over VR.
Mm-hmm.
Your final answer is I over VR.
T equals I over PR.
You see, Professor, that one is a little more simple.
Right?
Yes.
All right, how about this? This is a really easy question right here. Even though I tried to make it hard. So we have 3x plus 4y equals 12. And I want to solve for y. Tell me what to do. Minus 4y, no.
Okay, first you take that X and you put it 0, right?
Okay, how do I get it to 0? How do I get rid of a 3x? How do I bring it to the other side? Tell me. 3 over 3? So like this? Like this? No.
No, we're not dividing.
How do I get rid of 3x? That's what I want to do, separate them. Yeah.
We saw that twice.
Mhm. You tell me which one.
Maybe we should subtract because it's addition.
All right. Yeah, so we're gonna subtract 3x, right? But what I do to one side of the equation, I have to do to the other side of the equation, right? You said that? I thought you meant division. So look, I got 4y is equal to negative 3x plus 12. What do I do after that?
You have to add before you subtract because of PEMDAS. No.
I want y by itself.
So now we do it again? So now we
No.
do 4y, take away 4y, and then.
I don't want to get rid of the y. I want y by itself. So I want to get rid of the 4. How do I get rid of the 4? Divide, right? So I'm gonna divide by 4 here. But what I do to one side, I gotta do to the other, right? So now what's my answer? Y equals -3 over 4 x plus what's that, 3?
Okay.
That's it. No, this is it. Mm-hmm. Nope, just solve for the variable that's in question. Any questions on this?
We do more. I'm sorry.
Yeah.
Wait, how did we get that?
12 divided by 4.
Maybe if you do a couple more problems, then maybe we might have it.
Got you.
This is not something that I could just do like once and be like, yeah.
Got you.
So when questions like this, you're only solving for why, it'll always be why.
It depends on what the question tells you. Like remember when we had the IPRT, we're solving for T. So it's whatever the question tells you. Yeah. Mm-hmm. You try. And then we'll go over it after.
Oh, -3 over 4 shady, right?
Because it can't be simplified.
So I, oh.
For this question, I got 2x minus 5y is equal to 8. Go ahead, do it. Nope.
Oh, no, 5y plus 5.
Take away.
I don't touch what I want to solve for.
Take away the 2x on both sides.
But why? So I thought that you do the negative of whatever side is there.
I know what he did last time, and the one just. I'm just gonna try. You're trying to find the line, babe. Yeah, you wanna keep the line. Yeah.
No, I know it was wrong there. What I'm saying, it says 2x take away 5y equals 8, so I thought that you would do it 2x plus 2x. And then 8 plus 2x, so I thought.
So 2x and a whole number, they're different terms. They can't be combined. Right?
I'll wait.
It's not bad, right? Let me know when y'all finish trying, then we'll go over it.
I'm waiting for you to go.
Be careful with them signs.
Yeah, I'm just waiting for you, let's go.
It's on your homework, by the way. It's a by hand topic. Yeah. I think homework 13. This is it. Something like that.
It was really complicated.
Yeah.
Cheating.
'Cause all you have to do is solve for y, this thing. And you're good to go.
Yeah, he said to cancel out the 2.
Mhm. On the other side.
And then on the other one.
Mhm.
Wait.
Mhm. You probably got it. I trust you. You see?
I'm just trying to keep patterns. This is it right here.
Yo, that's what's up.
That's it.
Good job.
All right.
You almost had the signs is what got you.
This part, right? So it's
So like, so it's not just the 5, it's -5.
well, all of them.
Yeah.
Yeah, right. So this part is that number is right, but it's supposed to be negative. Or no?
It's just this. It's just this.
That part's why I messed
Yeah,
up.
not 16. They can't.
No, it's not 6. That's 0.6.
Oh, you did it in a calculator?
I sure did.
Bless your heart. It's all that.
Why?
Yeah. So look, all I want to do is I want to solve for y here, right? So what am I gonna do? Whatever you're solving for, you don't touch it. Leave it alone, right? You touch everything else. So I'm gonna subtract 2x from over here. But when I do the one side of the equation, I have to do the other side of the equation. So now what do I have? Right? I have negative 5y is equal to negative 2x plus 8. Right? It's okay. If it's reversed, that's fine. It's the same thing. Right? Yeah.
Why?
I switched it around, that's why.
That's fine. Yeah.
Yeah.
Why? So, mhm. Yeah. But you got the right answer. That's good. So,
Oh, solve the variable. You know what? That's-
exactly. Exactly. That's what the lesson was about. Right?
Actually gonna solve.
What you're doing is you're moving everything around to isolate the variable. That's what you're doing. Right? So I'm gonna divide by the negative 5 because I want the y by 2. No, that's not the final answer. So the final answer is y is equal to a negative divided by a negative is a positive. So it's just 2 over 5 x, bless you, minus 8 over 5. This is your final answer. That's it.
But I'm not writing my fault.
He basically rewriting more.
So they want us to solve for y. We solve for y. Now we got y by itself. Y equals blah, blah, blah. Yeah, that's it.
Well, it's not some people look at.
Yeah. Uh-huh. What's up?
Being there, cause, I did look at the river, 8 divided by 5.
Mm-hmm.
If you can't get a whole number, just do it to a
Yeah,
fraction.
just leave it
right?
as fraction.
All
That's
right,
it.
cool, cool. All right,
How would they give it, how would they give?
I did 8.
She got a decimal.
By -5, and I got negative 1.6.
Yeah.
And then you gotta turn that, you gotta turn that into a fraction.
I
Just leave it alone.
Just talk with
Just leave
you.
it.
Then you told me I was wrong, so then I'm thinking I take this plus out, put the negative, but I didn't think to put it as a fraction, like I would still put minus 4.6.
Yeah.
I think that would be fine, you'll still get full points for that.
I hope so.
It's the right
Yeah.
answer still.
Yeah. So that's that. Questions on this topic?
Want to do another one?
Yeah.
You want to do another one?
Yeah.
All right, fine. All right. Let me just think about something. Let's make it hard. 7x minus 9y equals 63.
Oh, yeah.
Yeah.
So,
Solve for y. Yeah. I was about to put 69, but I want to keep it PG.
when seven is positive, you have to, when it flips to the other side, it becomes negative.
Good.
Mhm.
Think of it like this, right? I have $7 and I want to get rid of it, so I have to subtract it. You know? I haven't checked my email for today, but I'm not sure if there's any events happening on Thursday. Tomorrow. Yeah, I should still come to campus and like search around. Um, oh, by the way, what's today again? And what happens today?
It's the last day of the Libra season.
That's true. That's true too. What else is happening on campus today? It happens every 2 weeks.
Somebody got English.
No, every 2 weeks. Jeez. Huh?
This doesn't make any
Oh.
sense to me.
What happens every 2 weeks on campus?
Every, oh, the pantry.
Pantry.
Oh,
Right?
don't.
That's today. All right, good. Low hall, downstairs, the first floor. Yeah.
63 over 7x?
Mm,
No.
subtract. So 7x, good. And then just divide by -9 on both sides.
Oh, so after I cancel out the 7x, right? Because obviously I'm doing 7x, take away 7x, cancel, and then 63, take away 7x. And then what?
And then just divide by the -9.
So -9 divided by 7x?
So by both of them. -9 divided by 63 divided by 7.
That doesn't make sense, Professor. Professor, it doesn't make sense. Never mind.
You got the answer?
I feel like I did, I don't think I did it. Well, I did a lot.
You ain't gotta use it in the calculator, just leave it as fraction.
I believe it's correct.
Yeah. So,
The last part,
good job.
should I switch the ending?
No, you good.
Like that.
Are you good? I'm doing the exact same way. Yeah. Yep. So look, first step, I'm gonna subtract 7x from over here. What I do to one side, I gotta do to the other. Mhm. Nah, this is it. And then now what do we have? I have -7x plus 63. After that, I want to divide by -9 to get y by itself. When you flip what? Mhm. It just so happens that that's going to become positive because a negative divided by a negative is a positive, right? So this becomes y is equal to 7 over 9x minus 7. And that's it. Mhm.
Because you did
Good.
6.58.
Mhm. By -9.
So,
Mhm.
can you see it really quick?
Sure. This is it.
Hey, wait.
It's good. It's good. Mhm. -9. So whatever is in front of the y, yeah, it doesn't. Don't touch it. Yeah, leave it. Yeah, yeah, right. Mhm. Mhm. Alright. So we good?
One more?
One more.
Yeah.
I want to go back to probability. Yeah, the easy stuff. This is hard. Mhm. Yeah. So
Look at what.
this is solving literal equations. Yeah. Mhm.
He says, so
Mhm.
the equation was 7x, take away 9y equals 63, right? I put solve for y. It said to divide both sides by -9. Oh,
Yeah.
frick, that was the first step.
Oh,
That was the first step on ChatGPT.
no.
That's the look. Show me what I did over here.
Yeah, I thought she was getting there.
I don't understand where these numbers came from.
You didn't have to do that. Just 63 divided by -9. Yeah. Because this isn't it? 7 times 9 is 63? Yeah, so that's it. Maybe you did the reverse. Maybe you did 9 divided by 63. Yeah. Hmm. I'll blame your calculator, not you. Yeah.
It's okay.
Mhm.
They're both because one is positive and one is negative.
Then the answer is negative. Mhm. Yeah. So we good with this? All right.
Fine.
It's one. All right.
But we don't have to like go over it.
It was something hard.
Let's talk about third time.
Um, I don't know. -15x plus 5y equals 125. Solve for y. Yeah. So as a little commercial break, right? Just going back to the story from yesterday. I heard that they found a lady that left the baby. Yeah,
Okay.
yeah, on 34th Street. Yeah. So, like as you said, they arrested her. Yeah, they found her and they arrested her and everything. Yeah, yeah. But like they got her for what was it like? Like she put the baby in danger, and yeah, 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 yeah. Now here's the thing. No, at 34th Street in Manhattan, yeah, in the train station. Yeah, yeah. But but here's the thing though. I thought that she was a young girl and didn't know. I was disappointed when I found out she was 30. I was like, what? I was like, what? Yeah. Right. The fire department or a hospital. Like you could literally just go there and say you don't want it and they'll take care of the baby. Yeah. 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 Yeah.
Yeah, I don't feel bad for her.
No, but I thought this was like someone who was like 14 or something.
No,
You know? Yeah, yeah, that's what I assumed. But when I saw her age, I was like, come on. So then we're gonna add. Yeah, the 15. Let's get rid of the negative.
I subtracted it instead.
You gotta always do the opposite.
But you didn't do the opposite when it was.
Because the other problems didn't happen. Sorry.
I give up. I'll try.
You can use the draw function on the word. You see what it says draw? That's how.
Like, do I have to search that function?
No, it's at the top. See, file, home, insert, draw.
Yeah.
Look at the top. The draw. And then you can draw like how I'm drawing. Boom. So not
Does
negative.
this stay like this?
So what you have to do is the opposite. How do you get rid of a negative 15?
You turn it positive?
Say,
I did go there.
but okay, so it's positive here, it's positive. The rest of it's I don't understand this, but this turned out to be very nice, right?
So it is the right answer?
That's the right answer.
And I can't, but you couldn't simplify this because
Right,
it's 7 and 9.
right.
And you
That's
couldn't,
right.
and you couldn't do it well here either because
Right.
this number is smaller. So when it looks like that, you can.
Right.
Okay.
When they go into each other even,
When they go into each
Yeah.
other, but when they give it,
just leave it as a fraction.
just leave it as a fact.
Yeah.
Okay.
Yeah.
This is on the homework, right?
Like 13, I think. Or 14. Got you.
Oh, wait a minute now.
But what do we?
First.
This reverses, all day people have been telling me to reverse. What is going on? What about reversing?
So the fraction, the 15 should be on top of the 5 and the bottom.
Oh.
Yeah.
No, I switched it.
All right, let's look at it.
So.
I'll try it. Okay. That's good.
Okay.
But it already had a plus right there.
Mm-hmm.
Yes, it's add, yeah. Right.
First. Yeah. Yeah.
Wow, that's what it is now. This reverse,
Yeah.
mixing things up
Yeah.
to like,
I got you.
take my time.
I got you.
I'll be back with it.
You know, there's people who do that though, like they read stuff backwards.
Yeah.
So it's pretty cool. Yeah, for real. Yeah. Yeah.
Think about it.
All right, so let's try it out. So I want to get rid of a negative 15x. So how do I do that? Right, so I'm going to add 15x over here. But what I do to one side, I have to do to the other. So now I got what? 5y is equal to 15x plus 125. After that, what am I going to do? I'm going to divide by 5, right? To get y by itself. Doesn't change. So y equals 3x plus 25. And that's it.
Yes, not bad.
So you did 15 plus 15, negative 15 plus 15, and then you did 125 plus 15. Yeah.
Because what you do to one side, you have to do to the other. Yeah,
Not right now with cover stuff.
got you.
Plus three. Why don't you put these Excel and break it? I know.
Because I don't save them. That's why.
Watch the video.
Got you.
Can you?
I could. I don't save them. I don't save them though. That's the issue. Like I just delete them after class. Up or down? This way? Okay. So, you're welcome.
Professor, so after you did negative 15 plus 15, and then 125 plus 15, after that, you ended up with 5y equals 15x plus 125 over 5.
Well, no, just that. So that's when you divide it, you get 25. Like in the answer.
I'm so lost. How do we get?
So I want y by itself, but there's a 5 in front, so I'm gonna divide by it.
Negative 15 plus 15, and then 125 plus 15.
It's the same thing. Here's 15x plus 25, 125.
Shit, you do a problem.
Yeah.
Okay, it's fine. I'll just do what I can at home. Wait,
If you have them reversed, it's the same thing. You know? Yeah. Go ahead. Yeah.
You got like a more?
Yeah, I really appreciate
There's
it.
one over here, if I know where.
It's, I would say like a plug in. Yeah.
Go ahead. It's fine. There's no right in the middle.
What, this one, right?
No, right here. Yeah.
So let's say that 15 is A, right? B equals to that, 1, the C is 125. And to problem look like this. Wait,
Oh, yeah, you doing the formula machine?
no, no.
This is your way. Yeah.
Trying to like show her way to plug it in, like how I kind of.
I appreciate it. Thank you. No, I don't mind.
So what's the problem is this plus the 5.
Professor, can you go up so you can see my equation?
Oh,
Yeah, a little bit, yeah, okay. Equals.
Yeah, this negative, so negative 15 x plus 5.
Yes.
0.5.
So that's
So then we do minus A on both sides. Then you cross A out, bring B down. Now it's gonna give you B equal to A plus or minus, if it's, being that this is positive,
Yeah.
this was what, negative? It makes up what, a negative? So instead of, see, I fucked up, I'm sorry.
Yeah, no, it's okay.
It's negative A, that's negative, it's
So that's why you said plus 15.
Yeah.
When you switch it to the other side, it becomes the opposite of what it was on this side.
Exactly,
Yeah.
basically.
So even though you're adding 15 to the 15, are you
This is
telling me
gonna
that
be-
you're gonna subtract it from C?
No,
Okay.
no, cause, alright, this after we got the subcategory 15, negative 15 plus 15 is 0, whatever, we can't do none of that, so we got X.
So it crosses out.
But you can't just throw X out, so you need to put it on this side, cause remember, we want B, the Y by itself.
To one side.
You gotta do that.
Exactly. So now you got A over here, AX, I hope that, let me not, plus C, and then divide by B. Divide
Which is five,
by.
and they divide both of them by five.
Yeah.
and
That,
then
see,
you
that,
have
if
Y.
it's a different sign, you don't change it. So if
Yeah,
it was negative, you don't change the negative this time. Yeah.
but if it was positive, that's the only time you do. Being that it was a negative, you switch it. So then you get, if you can't do this, like if you put on your calculator and that don't make sense, then it'll be, you just bring that down. But if you can, being that, you know, 5 and what is that, 15, 5 goes into 15 3 times. So divide, you get 3.
Oh, man, those markers,
It
man.
is. I say that.
Then 125 goes to 5, 125 times.
Yeah.
Yeah, that's fine. But if it doesn't go into it, then you
You just
leave
bring it
as a
down to-
fraction. You just leave it as a fraction.
Yeah.
I prefer fractions.
Yeah, but
Okay.
sometimes you don't. I think we could do a last one.
Another one.
Professor, it's gonna be time for us to go anyway, so we might as well just.
You wanna erase that or leave it?
You leave it.
Oh, yeah,
I
we
feel like
got
that's
this
kind
one.
of confusing.
Yeah.
It makes sense.
Yeah.
I like the see plugin, that's like so.
Tonight.
No, it's simple.
Oh, okay.
Yeah, the HBSC plugin is like so much more simple.
Cause A is gonna be X, B is gonna have Y, and then C is gonna have them. That's how you.
Let me try this.
This paper, because it's empty.
I look down at the date and that's the year that it is right now.
2020.
So like, Professor, like, if this is on the test, you're gonna be like, solve for Y or find Y. Because on the test that we just had, there was some question at the end. It didn't really say what I'm supposed to do.
It didn't?
No, it didn't specify.
It didn't say like evaluate or solve.
Actually.
That's it.
Okay.
So this is where I get lost. I'm trying to plug it in like she told me to.
Mhm.
So I get 20, -23 plus 23 cancel
23x.
X, yes, of course. And then I'm doing it on the other side, like you said.
3x.
So 2025 plus 23x.
Mhm.
Am I actually adding that? No,
23x.
so instead it's gonna be, 17y equals
Negative 17y.
25 over, yeah, I put it over. So instead, that's what it's gonna look like?
No.
No, so I was
With-
doing
with
it
the
right.
X. So now you just write these next to each other, that's it. They can't be combined.
So.
So negative 17y.
25 plus 23x,
That's it,
and then I have to do plus,
not plus.
oh, it's a negative.
But it's being multiplied to the y. So how do you want to do multiplication? What's the opposite of multiplication?
So 17 divided, -17 divided by 17.
Multiplied by negative 17.
-17,
Right.
20, 25,
Divided by
divided by 17,
negative.
-17. Okay, let me use my calculator.
You don't got to, you just leave it.
Okay.
17 is prime, so don't worry about it. Huh? Mhm.
Wait, I'm kind of.
I'm stuck on the negative.
119.8.
Dang.
-119.
Just leave it as a fraction.
So just put 20, 20. So why?
It's positive when the positive is bigger, right?
What do you mean?
Like the 23 and 17 divided by 17, the negative 17. 23 is bigger, so it's positive.
Is it
Depends on the sign.
2025 over 7? Is it y equals 2025 over 17 plus 23x?
That's 23x over.
Over 17 as well?
Mhm.
That's so stupid. What
Yeah.
is this? That's
So that's not, did I do this correctly?
I'll show you another way you can do it. See.
I just gotta
That's good.
That's good?
Yeah,
And
I see.
I'm weird, same thing.
So here's another way you could do it, right? Say you want to add 23x here.
This is the right.
It's so stupid.
And I'm going to add 23x over here. So now I have negative 17y equals 23x plus 2025, right? Then I'm going to divide by negative 17. When I do to one side, I do to the other. You can do it like that.
That's a little more simple for me.
And then, but just realize what it means. It means this 23 over negative 17x, right? Minus 2025.
It's okay, Professor, at least I'm trying.
Yeah.
As long as I'm trying, what we have complained about, all you have here in life is trying.
Yeah, that's what it is, okay.
So wait, that 23 though, that you just left it on, it's not negative 23 over 17, it's just 23 over negative 17.
It doesn't matter.
Why doesn't it matter?
If you want, I could put the minus sign up top. That's cool. Same thing. Yeah, you can do it in the middle too. I got you.
The specific way, you have.
I got you. Huh? Nah, whichever way.
I have to have faith that as long as I'm writing notes and I'm paying attention and I'm trying, that some way, some fucking how, it's gonna click out and see. Oh, no, so that's how I play it.
Ah, that's it.
Yeah, don't read. That's what I try to do. I'm gonna get more.
I wish I knew.
Exactly.
This is the simple way. All right, so tomorrow.
Wait.
Mhm.
I'm not a math teacher.
Yes, you are.
No, I'm not.
Solving literal equations. It's not on it. There's no formula for this. It's just solving for a variable. That's all.
When my daughter was pretty young, we used to use,
Have a good night, y'all. Uh-huh. Oh,